Hey, how's it going, guys? So here we are back again at the Python BACnet Stacks Playground. So I think this is just going to be a theory lecture. I'm trying to get a little bit more into back to doing these lessons. We're on algorithms now. It's part of the AI generated computer science coursework for some daily mini lessons. And we're up to day 27. I need to jump back into this, but we have been doing this basically using AI to generate this skills architecture. So yeah, radical difference from Vibe Code app 10 and 9. We were doing more traditional software engineering approach, like really pushing AI to use some specific framework, use some use we're telling it what to do and pushing it, kind of like a classic example of coding. So now, like, what I'm really curious after like all these days with like OpenClaw is to just see if AI can build it, and I think it can. It has been running. So like there is some of this. I still have to get to explore this. So this is kind of comes from like the basically this is just turning into a huge repository of like what AI is supposed to do. It's supposed to go and handle these build checkpoints. So yeah, this is just turning. It looks kind of nasty right now. So I still have to like wrap my head around it, but I think it's kind of like going in the right direction. We're basically every cron service, every call, every hour I'm doing, it can make 3 API calls to Codex to the OpenAI. And it's supposed to, yeah, it's architecting itself. It's building itself, and it'll maintain itself, and it'll run it little by little too. So it goes way deep into what it's supposed to do for BACnet drivers. So yeah, I still have yet to explore this. Yeah, it's basically it's telling it like what to do, how to make BACnet drivers, how to make trends and alarms. Very generic, kind of a specifications for a building automation system. So yeah, I've yet to see how this will turn out. But it is building something, so I can already see that it created a login for me. I just can't remember like what the login is. So like we basically give it the specification, and yeah, it'll basically create a login. So there's more to come on this. It's just kind of in infant stages. So we'll probably have to add in like legit login, but I can see it like I'm just checking on the code base and also looking at my Codex usage. It's just like shrinking and shrinking, so that means it's doing something. So I can see it like through the analytics here through OpenAI Codex that it's using my what I paid for, and it comes with $20 a month through ChatGPT, like I talked about on the last couple of videos. Okay, so more to come on that. It's kind of fun. So this is really exciting to me. I just have to like wrap my head around a little bit more on what it's doing and what it's building. So let's just see if it has this ready. This is just like a back end. We talked a little bit about back end, and we talked a little bit about front end. So actually we'd have to steal this URL right here. Let's just see if it has this ready. Okay, so I'm getting redirected for a login, which is good. It's building in authentication. So, and each iteration is supposed to, build itself. So I think like what this would be is like when I was a building controls technician, picture like Johnson Controls, or I did do a lot of school district work for mechanical contractors, is like when they're building the building, let's say it's a school district and there's a intense project in the summer. Very common for school districts to build a new school or to do some radical remodel. So let's say, we set up this AI tool on the existing building automation system, if this was a building automation system, and as the electricians keep on building and getting devices online, keeps checking. Hey, I'm building. All this is online, and then there'd have to be like some user giving it more context that like this is a boiler system with a chiller and a reheat system, unit ventilators or whatever, four pipe, hydronic system, and then the AI is getting context about the building and the design, and it keeps on checking the box like, yes, we got this device online with this device and this device, and then someone would be able to chat with it like, I'm not ready yet here, this device is offline, this device is flaky. So basically the contractors can still run around and do their thing like they do when they build buildings. It's not any different. This is a tool that's continuously working and checking the boxes until it's met its acceptance criteria. So I'm really excited about this. Okay, so next let's just I have to shut up and then start getting into this day 27. Actually I think we're on day 28 now. So like just shut up and start doing algorithms, and then we'll slowly be checking on the AI build process for the next couple days, and making, I'll probably be pushing updates and just trying to learn a little bit more like what it's doing. Last time I looked, it used Fast API once as its backend framework, and then the next time I saw it build something with using a built-in web app service built into Python that I think is more for like test purposes. So it's it's building stuff. But yeah, so this is cool. Okay, so let's get back into the theories. I just need to open up VS Code. So I might just start putting okay, I'll just open up VS Code. Okay, so algorithms. So anyone not interested in algorithms, feel free to sign off. This is just like some computer science theory of going over we did all of the basic syntax, operators, did data structures, basic data structures, and now we're doing basic algorithms, and then kind of eventually get into some more advanced algorithms, and then into doing more advanced data structures, specifically around RDF, the Resource Description Framework, which is what the smart building industry has adopted for data models. So that's coming. That's like day 60, I bet. So I just have to shut up and then just start doing this stuff. I was kind of looking at this a little bit prior, so a little bit of code in there still. So right now I'm in VS Code. Just opening my local directory here for the project in my script lesson. So this is just a generic Python file. And there is a little bit of data here. So the list data structure and another list filled with timestamps. So yeah, let's get to it. Chop chop. Okay, theory. Okay, so algorithms, like the goal is to implement a linear search, scan a sequence body order until you find a target. We've done some of this before, like you brute force your way, I iterate through one component at a time until you find something. Linear search, it's called linear search. In computer science, they call it O to the nth complexity, is the worst case that you inspect every algorithm. It's very inefficient from an algorithm computer scientist standpoint. I think we'll get into more efficient algorithms as time moves on. That is acceptable for small backend points lists or short trend slices. Okay, so like it works. Find the worst occurrence. It works on unsorted data. So some of the other algorithms that we might get into that are more advanced and efficient than O to the nth requires the data to be sorted. And like what it means by that is like all of this data in the list would need to be in chronological order from lowest to highest. As you can see, it's just like a random number of floats. values of kind of probably what you would see in a temperature sensor value or whatever in the real world. Okay, so this is just some, it's just like you brute force your way through the list for an item and enumerate. If the item equals a target, return the index, basically. Same thing here. If for an item in enumerate, that means you enumerate through each value in the list, and then you can return the value and the index. Remember the index, like this? This is a list of data. The index is 0, index 1, index 2, index 3, index 4, so that it all starts at 0 for whatever reason. Mini examples, I might just write into this. So, okay, micro examples. Write first negative index flows, returning the first index where airflow is negative or -1. Okay, so we might just say, let's pretend these are airflows. Let's call it flows. Put another value. We can pretend they're cubic feet per minute in the data. And let's add in 1 that, hey, there's something wrong with that airflow measuring station, and it's bad sensor or something in it, and then now it's returning minus 0.02 cubic feet per minute in your airflow measuring station data, and it's just some anomaly. So we can make some, we can use a computer science algorithm to iterate through it and then find out where that is. So write a function here, returning the first index where the CFM is negative or -1. Okay, so we have to do a function. We covered functions basically. So function in Python is like that. And then flows is here, so we'll pass that into here. And then we can do I think we have to do the same style of for I and enumerate. I suppose I can just write this. I might just do it the old-fashioned way. For I, flow in enumerate flows, and we can even print I and flow. And if we call this function, we can see what the data looks like. Okay, so if we do Python script, oh wait, I have to change to the root directory. Change to the root directory here. Stupid thing. Python script lesson. Okay, so we printed this. This printed these values here as we iterate through our data, and then we would just have to do some basic operator here. That would be like if flow is let's see, less than or equal to 0. You do less than equal or equal like that to 0.0. Actually, we need colon there. Print I. And then I can't remember that there's this actually. Remember we did operators. It's like a continue, and then actually I think we can just do return. This will stop the program. 4. So there it goes. It printed this value 4, index 4, 0, 1, 2, 3, 4. So then we can just say return I. That worked. Okay, and then like if anyone's like watching this and like, why are we even doing this? It's just to, the more that you practice this stuff, algorithms, the better you'll be in software engineering. It's like very well known in industry. Really good software engineers push themselves through data structures and algorithms and mastered it. So it's just kind of a foundational background. So that's why. Okay, so did we do that? Write the first negative index, return value. Okay, so we did that one. Given parallel lists. Okay, so this is timestamp and the outside air temperature. Okay, so this is the other data. I might actually just use this. So it wanted a list called OAT. Okay, we'll probably just write a new function. And then what was our outside air temperature? Return a timestamp of when the index, where outside air temperature is greater than 35, or return none. Okay, so let's just say these are degrees Fahrenheit. Let's pretend this is winter, so 20 degrees Fahrenheit is below freezing. There'd be frost on the ground. Got one too many equal sign there. So okay, so how many of these do we have? We have 7. And 1, 2, 3, 4. So we need a couple more values. Let's add in that value. 44 is nice and mild. I can do one more. 1, 2, 3, 4, 5, 6, 7 timestamps, then 1, 2, 3, 4, 5, 6, 7. Okay, so we just need this list to be the same as that to be the same length. So I think we can do combined data equals zip function of timestamps and outside air temp, and I think this will make a tuple. Print. So we kind of covered what tuples were before. Okay, so that made some. Oh, I can't remember what to do after a zip. Maybe we have to do for item in combined data. Okay, so that's another. Okay, so maybe we'll Google this. I can't remember. We played around with the zip function utility built into Python before. And then Python, how to iterate through data combined with zip function, which was 2 lists, same length. Okay, so I'm just going to Google this. Okay, so they're doing it as they're zipping it. So we could just say for stamp and temp in zip, print stamp and temp. And then we could turn it into a function. Okay, there we go. So there's our data here. Maybe I'll zoom in one more time. Given parallel lists of the same length, return the timestamp of the index where the outside air temperature is less than 35. Shoot, I think all of mine are less than 35. we can change that. So I'll change them all to 4s. How about now? So this should be index 2, 0, 1, 2, which we need to return that timestamp at 5:30 in the morning. We had some cold outside air temp. Okay, so if outside air temp is less than float of 35, print that. Type error, not supported. Okay, so between list and float. So I think like we need to do if, oh wait. I need to use this. I was using this whole thing right here, and I just need to compare this value right here, and I accidentally had outside air temperature here. So I was trying to compare the whole list of data to the single value, float value. So that won't work. Okay, so that returned my correct value I was expecting, and then I just need to return a timestamp. I could actually put this now. Maybe we should make this into a function. We're going to call this return. Then we could actually just make it a function out of the def. Okay, so this could be stamp finder. I'm just going to call it pass these guys into the function. Okay, and then we just have to basically call the same thing down here, and this should work. Actually, I think I need to print this. Print. Okay, so that did print right here. So this function did its thing. One thing to note, I don't think this makes a big difference at all, but like, so like this is like this is outside air temperature, this is our raw data, which we need to pass that in here when we call our function, and then it feeds it in again. So it feeds in all this information and returns this. Like we could just call this something unique as, let's just say, just do something different. Time. Let's just call it T. Call it T1, T2. And then these just have to be the same here. I just want to try and prove a point that we'll get the same result. Okay, so like these names have to match these names right here, but then as soon as we call our function, these can be unique as long as they match here. I think like what happens behind the scenes is that the machine level code, these are assigned different variables. So even though like this is the same name, which it needs it, like once it goes inside of the function, there's something probably with every computer programming language, like once it's inside of a function, it's like, think of it as different data. They're separated under the hood. Like you, once it kind of passes through the function, like the data, if you would look at it on machine level code, not human readable, it's different variable assigned names and everything. So just keep that in mind. Little things to note, like once you pass things into functions, different things happen under the hood there. Okay, so number 3, last one. Extend linear search to return all indices where target occurs. Still one pass append to a list. Okay, so what could we do here? We could do, maybe we could do return. So this is just a list of data. So we could do count the amount of times that the temperature is in between 40 and 44. So on the low end, let's just do if temperature is less than 44. Okay, so I think like we need to, let's try something. So this is like, call this occurrence equals a list. Empty list is a data structure we've talked about. And then we want to create a condition that, temp, outside air temp is 40, is in between 40 and 44. Okay, so we would say that if temperature is less than 44, if temp is greater than 40, and I think we can do operator like that. Maybe we have to use and. Then what we want to do is append. So we want to take the name of that list and then do an append, a tuple of stamp temp. Okay, let's see if this will work. None. Well, that's not right. Okay, so if the temperature is greater than 40 and the temperature is less than 44, for one thing I spelled occurrence wrong. Not that that would make a difference at all. Oh, I know what we need to do. Then at the end of the program, after we iterate through everything, we need to return the data. Okay, it did it. So it picked out of the data, put them in list tuple data structures, and then it packaged it into a list and then returned it, and then we printed it. So hopefully that makes sense. So basically our functions, stamp finder, we created an empty list here. This is technically, this one, T1 is the timestamp, T2 is the temperature value, and then for stamp and temperature, in zipping these two lists together, we just created a little operator here. Here's our condition logic right here, and then we append this list, and then we return it if that condition is true, and then we print it at the end. So pretty basic stuff. So I think like the theory, computer science theory in this is that we're iterating through each one of these linear search O to the nth complexity, and it's very inefficient from a computation standpoint. This stuff gets really hard. At some point in time, I'm probably going to be fumbling a little bit, and as soon as we get into the more advanced algorithms, because there will be like, there's more advanced computer science efficient way of searching. So that's yet to come. So hopefully you guys are liking this. I'm going to stop here, and then maybe each one of the computer science theory lectures, we can just chat a little bit about how's the vibe coding going. Because this stuff is, AI is kind of AI is doing all the software engineering. Well, we're kind of being the architect, and then AI is kind of being the coder, the programmer, the software engineer, and us, the humans, studying the theory, will make us better, stronger, faster, guaranteed. It's another thing that I've been really curious to get is like, I want to do a Linux Plus certification. I might do this. Linux Foundation has certifications too. So does CompTIA. So this is also another thing like to buy. So it's a IT certification for Linux, which I think is super valuable. If you're interested in any of this stuff, maybe I could cover this later in time, is to do a Linux certificate. Networking is also one. There's also I have one on AI. Kind of silly. But networking is a really good one to do too if any of you guys are into building automation systems. We kind of know enough to be dangerous about networking, so maybe I'll do that one too. And then A plus is a really good one too. I did this a really long time ago at a tech college when I was a building automation technician. I took, just starting out, I took an electronics AC/DC circuits course, which helped me in the field troubleshooting with electrician building automation installs. And then I also took this A plus, and now I'm thinking about, I might do this security plus, and then maybe the Linux one too. So, but first I have about 50 days of computer science theory. So hopefully you get where I'm going. So like once you build off the foundations, I think that's a hot skill set right now, is having a background in building automation, 5-10 years of experience with commissioning HVAC systems in the field and as a contractor, a field technician, and then combining that with the IT certificate, IT certs, that's a hot skill set, and knowing how to use AI, so you're off to like a really good career there. So hope you guys are liking this. See you tomorrow. I'm going to try and do one algorithm daily lesson. And yeah, I don't know, for some reason I've been really like treating the algorithms as something I know I need to refresh on, but like avoidance, like I'm kind of battling some avoidance here. It's just, I don't know why, but like, okay, so let's just see. We just did linear search. So tomorrow we'll do day 29, count occurrences. So it's not very hard. It's just, just a very foundational level of algorithms, freshman year probably of a computer science degree. You'd probably do this in Java or something. And then this might be getting into a little bit more half advanced algorithms, I guess. And I just realized they're not even that advanced. There's other sorting algorithms that I think can get very complicated, even from the foundational level. But I'm just looking at these, and they're actually not that bad. So maybe we can just plow through them. And then we'll get into a maze generator. So this is something I was vibe coding some games in Roblox with my son. We do a little bit of that too. And I made a Roblox game when we get to this point that generates a random maze. I don't know how the hell it did it. It's something that Gemini made in Lua, is what the coding language is for Roblox. It just made this random maze generator, and then the character could kind of bounce around the game, and like It's kind of mind-boggling. So there's lots of computer science theory in that, and then I guess like once we get past this, I'll probably take a breather, and then we get into advanced data structures for RDF theory, smart building, graph theory. So like we're picking pieces out of computer science that are most applicable to smart building industry, because computer science can be a very broad topic. But if we're kind of pigeonholed to working in the HVAC smart building industry like me, you probably only need to know just a little bit. So that's what we're doing here. So hope you guys are liking this, and we'll talk to you later.